Hello everyone, welcome to another episode of Deep Dive Knowledge Talk. What motivated you to explore the synergy between reinforcement learning, RL, and large language models, LLMs, in your research?
We were motivated to explore the synergy between reinforcement learning, RL, and large language models, LLMs, in our research, because we wanted to understand how these two powerful tools can work together like two superheroes joining forces to solve complex problems. By combining RL and LLMs, we aim to uncover how they complement each other's strengths and weaknesses to achieve tasks related to natural language processing more efficiently and effectively. In simpler terms, it's like investigating how a detective and a scientist team up to crack a mysterious case by using their unique skills together.
That's a fascinating analogy. Can you explain how RL for LLM, LLM for RL, and RL plus LLM are structured in your taxonomy and how these different classes represent the interaction between reinforcement learning and large language models in your research?
In our taxonomy, we have three main classes that represent the interaction between reinforcement learning, RL, and large language models, LLMs. RL for LLM, LM for RL, and RL plus LLM. 1. RL for LLM. This class focuses on using reinforcement learning to enhance already trained large language models. In RL4LM, RL is utilized to further refine and improve the performance of LLMs on natural language processing (NLP) tasks beyond their initial training process. This class includes studies where RL is applied to fine-tune LLMs or combine them with RL agents to achieve specific goals in NLP tasks. It essentially shows how RL can help boost the capabilities of LLMs beyond their original training. 2. LLM for RL. In this class, large language models are used to influence RL tasks. LLM for RL studies involve LLMs playing a role in RL by representing policy functions to be learned or assisting in the training process. This class highlights how LLMs can contribute to RL tasks by providing insights or guidance that can improve the performance of RL agents. 3. RL plus LLM. This class encompasses studies that combine both RL and LLMs in a collaborative framework. RL plus LM studies are further divided into two subclasses based on the feedback mechanism. RL plus LLM without language feedback. Studies where the prompt of the LLM is updated during the planning process. RL plus LLM with language feedback. Studies where the prompt of the LLM remains fixed throughout the planning process. Overall, these classes in our taxonomy showcase the different ways in which RL and LLMs can interact and complement each other in various applications, such as text classification, text generation, and more. Each class represents a unique perspective on how these two powerful techniques can be combined to enhance performance and tackle complex tasks effectively.
How do studies in the LLM for RL class demonstrate the assistance of large language models, LLMs, in the training of reinforcement learning, RL models for tasks unrelated to natural language processing? Could you provide an example to illustrate this concept further?
Sure. Studies in the RL4LM class demonstrate how large language models, LLMs, can help in training reinforcement learning, RL, models for tasks unrelated to natural language processing. Imagine you have a robot learning to navigate through a maze. The RL model is responsible for teaching the robot where to move based on rewards and punishments it receives. Now, the LLM can step in to help the RL model understand and interpret complex instructions or information it receives, making it easier for the RL model to learn how to navigate the maze effectively. In this scenario, the LLM acts as a teacher's assistant, providing additional support and guidance to the RL model, even though the task of navigating the maze doesn't directly involve processing natural language.
How does the taxonomy you proposed in your research help in understanding the motivations behind the synergy of large language models, LLMs, and reinforcement learning, RL? Can you explain how this taxonomy sheds light on the reasons for their successful collaboration and potential areas for further research in this field?
The taxonomy proposed in our research helps in understanding the motivations behind the synergy of large language models, LLMs, and reinforcement learning, RL, by categorizing studies based on how these two models interact with each other and the nature of the end task they aim to achieve. By classifying studies into different categories like RL for LLM, LLM for RL, and RL plus LLM, researchers can clearly see the different ways in which RL and LLMs work together towards a common goal. For example, in RL for LLM studies, RL is used to enhance the performance of LLMs in tasks related to natural language processing, such as text summarization or question answering. On the other hand, LLM-4 RL frameworks aim to improve the training efficiency or performance of a control task that would still rely on RL, but is not necessarily related to NLP. Lastly, studies of RL plus LLM use LLMs to plan over individual skills learned through RL. This taxonomy provides a structured way to understand why researchers combine RL and LLMs, how they collaborate, and what specific goals they are trying to achieve by integrating these two powerful models.
How does the taxonomy you proposed in your research help in understanding the motivations behind the synergy of large language models, LLMs, and reinforcement learning, RL? Can you explain how this taxonomy sheds light on the reasons for their successful collaboration and potential areas for further research in this field?